Countless wishes have been made on twinkling stars. Ironically, that twinkle is one of the things that can get in the way of finding out what they really are. Light from stars is refracted through our atmosphere in different directions, which causes the star's image to change slightly in brightness and position and can make them difficult to see clearly through telescopes. A small company in Massachusetts is helping astronomers around the world overcome this challenge to see clearer pictures of deep space than ever before. The firm's micro-electromechanical systems, or MEMS, deformable mirrors, help telescopes compensate for the effects of our atmosphere and correct for minor imperfections in the instruments.
And these mirrors have a number of small pistons underneath them that can move the surface of the mirror up and down to change the shape to control the light that bounces off of them. And through the NASA SBR programs, there's been developments in both the new kinds of mirrors and the production of new types of mirrors for specific applications, and also some new manufacturing technology.
Through research and development funded by Small Business Innovation Research, or SBIR contracts from NASA's Jet Propulsion Laboratory, Boston Micromachines devised a new manufacturing process that produces ultra-flat mirror surfaces. Through another SBIR award from JPL, the firm also improved the drive controllers that enable the devices to quickly correct for aberrations. NASA is planning to take advantage of these technology advancements to gather images of planets that orbit stars in distant galaxies. Imaging those planets directly would help scientists discover the nature of our own planetary system, but doing that requires some of the most sensitive instruments ever flown in space. Researchers at NASA JPL's High Contrast and Imaging Testbed are using SBIR-derived technology from Boston Micromachines as part of a new imaging approach that could enable a space-based telescope to see a distant planet that is 10 billion times fainter than its central star. Paul Bearden sees MEMS deformable mirrors as serving a critical need for that approach.
They have all the space qualities that you'd like. They're lightweight, they're extremely low power, they have almost no mass, so they have strength for vibration. They can operate in vacuum. So all of these things that are just inherent in the MEMS process work really well into what NASA needs for space missions.
MEMS deformable mirrors from the company are being used in space observatories around the world, and the cost-effective manufacturing techniques derived from the NASA SBIR-funded work mean that you may soon find advanced adaptive optics technology at your local eye clinic. The National Eye Institute of the National Institutes of Health recently awarded an SBIR contract to Boston Micromachines to develop an instrument that takes advantage of MEMS deformable mirrors to give doctors a clearer and more detailed look inside patients' eyes. This would enable earlier detection of eye diseases such as glaucoma, diabetic retinopathy, and age-related macular degeneration. It's a significant innovation that's bringing a twinkle to the eyes of researchers, doctors, and patients.